ก็คือ AI Deep Learning and New Computing Model นั่นเองค่ะโดย Mr. Nicholas Walker นะคะและช่วงท้ายเราจะมีการพูดสรุปโดยรวมนะคะเป็นภาษาไทยโดยคุณไพโรจน์ค่ะ Right now, ladies and gentlemen, for the last topic this evening at the workshop room 4, we still have another topic, which is AI Deep Learning and New Computing Model. And at the last of the presentation, we'll be having a brief summary in Thai by Kun Payarod as well. But first of all, please give a round of applause for Mr. Nicholas Walker. ขอเสียงปรบมือให้กับท่านด้วยค่ะ
Not sure how many of you were here a bit earlier, so seeing me again. My colleague was supposed to do this presentation, so that at least you get to see a new face, but unfortunately got stuck in traffic, wasn't able to arrive on time, so I apologize for that. So you have to bear with me once more. Now I will try to talk about something slightly different area of what we discussed earlier in terms of AI, and probably should have been the other way around, but you will now get a kind of introduction to what AI is, which is not something that we covered just earlier in my presentation. Now, I would just want to start with a video that NVIDIA made, and I think it's very important to demonstrate what are the potential of AI as a technology.
I am a protector, exploring the expanses of space to keep our planet safe, and all the species that call it home. I am a healer, giving doctors the vision to create amazing new cures. And using the heart's own magnetic field to diagnose itself. I am a guardian, searching a mountain of data to keep us safe when we travel. In a sea of people to find a lost child. I am a helper, powering autonomous machines that simplify our lives. Capture our greatest adventures. And make us whole again. I am a visionary, enabling taxis that don't need steering wheels, and those that don't need roads. I am even the composer of the music you're hearing. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Okay, well, I think it's a good way to kick things off. So I love that video because it really gives you an idea of how pervasive can AI be, right? And something that everywhere I go and talk, I want really people to get clear is that AI is no longer the future, something out there. It's not out there, it's here, and it's the present, okay? And I think that a lot of startups and a lot of enterprises really need to kind of absorb that as a concept and accept it, because otherwise they're going to lag behind in the market, and I think it will have negative consequences. So the use cases are infinite, when it comes to AI. These are our three common examples. Of course, understanding speech I remember 5 or 6 years ago, I was using voice command or Google Voice, and I just tried it as a gimmick, send email, to show it to someone, then never use it again. It was something that you show someone, oh, how cool my feature of the phone, but then we did not use it. Why didn't we use it? Well, number one, because often it was not reliable. It means that I had to try 6 times before I understood what I said. So that already the first put off. And the second one is that I had to remember command and tell commands to the phone. So I have to remember which are the commands they can accept. Of course, people will not, the technology exists, but they will just not use it. Today, most people still, have the chance to use Siri, to use Google Assistant, to use Alexa, to use Google Home, and so on. And the reason why they do it is because of AI. Because AI provided 2 capabilities to this technology. Speech recognition is nothing new. However, the ability to understand what someone is saying with higher accuracy, so I don't have to say it 6 times, is something that was new. And that was brought by AI as a technology. And also understanding different accents in different languages. Okay, no longer having a barrier just because someone is speaking English with a Singlish, English with a Singaporean accent, or because someone is speaking Thai. Okay, and the second one, for that particular example, is that when I speak to these systems, I don't have to give commands and remember the commands. I speak naturally to the system, such as what's the weather like today in Bangkok, right? I don't have to remember command. So that part, which is called NLP, Natural Language Processing, has also been very important because now we don't have to remember command, but we can speak naturally to the system, the same as we would do with a human. And then for us, it's a lot easy to interact. And that was and also of course the accuracy of the system to be able to understand what we mean. I can say one thing in 60 different ways. The question is, what do I mean? What's the gist of it, right? I can say, what's the weather like in Bangkok? I can ask, check weather in Bangkok. I said, well, can I ask what's the temperature in Bangkok? There's many ways to ask for the same thing. And as AI was able to provide the suitable technology to provide the services with the right accuracy, simplicity, we started to rely on them. So now many people rely on them. There's many people that has Amazon Alexa, and they rely on it. It means that they use it, they rely on it, and they use it consistently. This was not something that was happening before because the bar was just too low when it comes to usability and accuracy. And it's critical for any service out there to pass that bar so that it can be relied upon by the user. Then you have a product that you can truly sell and that you can truly have your customer fidelization happening. So clearly assistant, find where I park my car, right? So that's one of the questions you can ask. Also the ability to do recommendation systems, right? As I said, an example is Pinterest. You can take a picture of an article of clothing, and check where could I buy it. And very, very important recommendation systems. Now Netflix, for example, relies not on how many movies people watch. It really relies on people paying the monthly subscription. They don't really care, how much do you really watch? But they really want as many people as possible to have a subscription. Now, what's going to happen is, if you don't have good content, if you don't watch it, eventually you will say, well, I never really use it, they'll cancel my subscription. So, apart from having a very good selection, Netflix had to also put a lot of effort in making this selection searchable and also giving good recommendation to the people, right? And the recommendation system nowadays, based on AI, are a lot more advanced. If using a system such as just someone else, you just watch this, so other people that watch this, they watch that, it's not good enough. We are humans, we are complex being, and the fact that someone else happened to watch my same movie, one movie that we just watch in common, doesn't mean that we have, a lot more else in common, okay? So recommendation system have to take into account a lot more data, the profile of the user and historical data, to be able to be more accurate. And if Netflix can have a very complex and efficient recommendation system, then they can always have good content, and if there is good recommendation, you try them, you like it, and you continue to use it. If the recommendation is wrong, you will get disillusioned, and you will say, well, there's nothing for me to watch, even though maybe there is somewhere, just you cannot find it, right? And then you will stop using it. So that's how important for internet consumer companies such as Netflix can be important to have very good recommendation systems, and they spend a lot of investment in being able to fine-tune it and fine-tune their models to do that. So there is really quite a lot apart from internet website and services. Clearly healthcare, as we've seen, can be really useful in assisting people with disability, as well as of course other type of industries. One area that I wanted to touch on for Thailand is the agribusiness, agriculture. I work in with many countries in Southeast Asia, and I have to say that plantations can be an important part of the business as well for many of these countries, and there is enormous improvements and innovation coming in agriculture from AI. We have systems with a company, I think it's called Blue Water, I can't remember now, but there's a company that developed a system that has cameras, and when they apply either fertilizer or pesticide, what they do is that they only spray directly on the plant, and they will not do it blindly. So you can see they have a lot of nozzles, and they're able to be very targeted. Now this achieves two things. Number one is you're saving money, because now you're only really spraying on the plant and not spraying all over around, so you use less fertilizer and less pesticide. And even more important, you don't have as much the issue of fertilizer and pesticide runoff into the water system and all the issues that it can cause to the environment, right? So it's a win-win. It's a win for the environment and a win for the business. And of course the automation, having autonomous machine tractors that can go around and and be able to move the machine autonomously. As well, for example, I was looking in some companies at options to use drones with cameras to go, for example, inside a palm oil plantation. And this drone with the camera would go around, it would create a heat map, of the whole plantation, which often they're huge in countries like Malaysia and Indonesia. I'm not sure much in Thailand. And it will check, and the camera will be able to, the drone is able to autonomously navigate between the palm, because it sees the trees, there are trees, it knows that it doesn't, it shouldn't bump against them. And it will look at the plants, it will look to try to recognize if they have a disease, or it will try to look at the crop and see if the fruit is ripe and so it's ready to be collected, right? So there's incredible improvements that can be provided to make even agriculture more productive, safer for the environment and also for the people that work in it. So that's a particular area which I really hope I will be able to see more startups in Thailand exploring ways to implement this to get the country even more competitive while protecting your own environment. Of course, intelligent services, we know that banks and telco and other utilities are all very interested in being able to provide better services, right? Examples are being able to implement AI in the area of customer service, right? Chatbots. Chatbots is something becoming very popular. You now talk naturally, right? But the person on the other side of the system in the chat for customer service is not actually a human, it's a bot, right? But you can talk to it naturally. And this can help in provide better service, because now you don't have to wait as long on a queue to access customer service, right? You could have, in theory, thousands of virtual operators. And the other benefit, of course, is for the company to be able to reduce costs to do with customer service as well. And of course, also trying to profile customers, for example, reducing churn, or being able to do marketing campaigns campaigns that are more targeted. If I can ingest large amount of historical data, I know, for example, for a telco, which customer likely has a pattern that would eventually cause them to switch operator, right? Or maybe being able to develop, ad hoc customized marketing promotion for specific customer instead of being generalized to everyone. And of course, public safety. Public safety very, very important, including Bangkok is a huge city, and be able to use video to recognize faces, to recognize suspicious behavior and so on can be very important in maintaining all of us safe. So AI can really be seen as kind of the next stage in the evolution of our technology. We started with the internet, having internet at home or internet on the PC, moving then to the fact that now we are on the phone and we do everything with the phone, right? I mean, until a few years ago, we didn't use the phone for everything that we use it for nowadays. We use the phone more than we use laptops, Laptop sales have been, apart from work, really have been declining, People use tablets, and even tablets actually have been sold less and less because people just use the phone. You can do, every year you can do something more with the phone than the previous year, and so it becomes the most reliable, really, piece of equipment in your life, and a lot of people's life really seems to revolve around the mobile phone. So AI will be the next thing, right? And we've already seen it also in mobile phone, having Siri, having Google Assistant, all of these will be assistive technologies that we'll start to go and rely on, okay? And hopefully they will reduce the amount of menial tasks, repetitive tasks, because of the automation, because the system can predict what we need, even before we ask for it. So I think the IoT and also AI in particular is going to be the next thing when it comes to disruptive technology that's going to alter the way that we live. So if you're a user of AI, if you're a developer, if you're a startup, it's very important to remember that AI is not something for certain industry. It's something that spans across every single area, and so any industry can take advantage of it in one way or the other. This is very, very important, and you see that it's really booming, and the faster you get on it, the faster you're going to be able to go to market with a product and have a competitive advantage. So it's really critical that people and companies start to explore this kind of technology as soon as possible to be able to remain competitive in the market. Otherwise, other competitors might disrupt things before they can, and then that will be a challenge. Now, this slide actually is not really up to date because many people think that that number would be a lot higher in terms of spend, and it's getting also, I wouldn't say close to trillion, but it's possibly in the hundreds. So there is a lot of spend happening in the technology. Are they 3,000 AI startups today? Well, I think there is a lot more than that. I think that's a very, very, very old slide, I must admit. Certainly in NVIDIA, we have thousands of companies under our Inception program, which is for startups, and we give them a lot of benefit. So please go, if you're a startup, if you're interested in AI, do search for our NVIDIA Inception program and register your company. So the potential really is incredibly high. And there is a big ecosystem, you're not alone. You can actually collaborate with other startups. You can just be a component and then integrate it with other companies to make a final product or a final service. So we see here the progress from the early days of research where mainly a few research centers and universities were playing with AI and trying to develop services, all the way then for it being picked up by companies such as Google and Amazon. Of course, Google, relies now on over 90%, I believe over 90% of their product rely on AI, okay? And so on, and now we see, of course, the number of companies is really infinite, and we have a lot of leaders. I mean, with Alibaba, clearly, which has invested massively in this particular area, and there's many other companies in China, such as Tencent. And also we see also the pharma, or for example, with the vehicles, many of the automotive companies more and more invested in particular in these areas. Okay, so let's do some jargon busting. I mentioned AI, I mentioned deep learning. What does this all mean? Well, artificial intelligence in itself, I wouldn't really call it a technology, but it's something that we're trying to achieve. That there's many aspects to it. There is the cognitive aspect, decision making, memory, perception, emotion. Okay, and the main technique that people have been using so far is a group of really technologies and techniques, which we call as a group machine learning. Okay, the ability of a machine to learn, typically by using data. And within the machine learning techniques, there's one particular technique called deep learning. Now, deep learning essentially relies on ANN, artificial neural networks. And the reason why we use the term deep learning instead of neural networks, for example, is simply because artificial neural networks are something that have been around for a very, very long time, since the 60s. However, only recently, when we had the technology and the capability of using them for practical application, not for experiments or for academia, that we've really been able to take advantage of them for real needs, everyday needs. And so we call it deep learning because we are talking about deep neural networks. Deep neural networks are capable of doing more advanced tasks versus shallow neural networks that typically were only simple experiment and were not really usable for many practical purposes every day, right? So deep learning makes use of deep artificial neural networks to learn from data and be able to perform a particular task. And this is one of the ways that we try to achieve some aspect of artificial intelligence. And we have an example here of a particular neural network, a graphic representation of it. This one is, I don't know if it's AlexNet, I'm not sure which of the network it is. But it was used for a particular competition to try to classify images from this huge data set and be able to do it correctly. Typically that was being done by other techniques such as humans and also other machine learning techniques, but since 2012 pretty much the standard now has been the use of deep neural networks to recognize subjects of images. So really deep learning, as I said, it really spans across everything. So you have we have many examples here, okay, of potential use cases in a variety of segments or industries. And this is just a few examples. There's clearly a lot more than that. NVIDIA is also very invested when it comes to autonomous machines, both robots but also autonomous vehicles. We're working very hard in developing very accurate and safe technology that can help us, achieve, autonomous vehicle, level 5 autonomous vehicles, which can completely drive on their own and don't need a supervisor. So what is the process like when you do deep learning? So you have a training phase where you train a neural network to do something, and to train it you need to use examples. Okay, so think about like a flashcard exercise. So you have, if I want a neural network to train to recognize cats, I will have maybe 2,000 pictures of cats in different poses, in different scenarios, different backgrounds. And of course, each image will have to be labeled, right? Let's say cats. Okay, so you have labeled data that will be my data set, and I will use that to train the neural network to recognize. Typically, the more data you have, the more accurate will the neural network be. So that's not the only factor in question, but certainly the amount of data you're using for the training will be very important for the network to truly understand the concept, the pattern, and be able to recognize it then when we deploy it. Okay. So after that, then we will have a deployment phase for inferencing, in which we then, of course, use the neural network to do what we're trying to do. So, what NVIDIA uses ourselves, even because we have a huge cluster of this in our own facility, we use DGX1. DGX1 is an appliance that has 8 GPUs inside, and it's been specifically designed to perform deep learning training in the fastest possible way. So the advantage, of course, to do deep learning training, which is a very computational-intensive tasks using GPUs and using DGX in particular, is the fact that I said if I were to want to use CPU to do that, I would probably need hundreds of nodes to be able to achieve the same performance as a DGX appliance, right? So it's not really cost-effective in space, power, and so on. So it's very, very important to use the right technology to do this, and at the moment the best technology to do deep learning training remains the use of GPUs, supporting all of the different type of deep learning frameworks. And because it's so compute intensive, it takes a long time. If I'm a startup and I want to train a neural network to perform a particular task, then I will want to try different iteration and verify if I can be accurate and so on. So in those cases, when I do the training, one of the most important things to be able to go eventually to market with a product is to reduce the amount of time it takes to do this training. If on average, I think that at least 100 iterations of training will be required before, in many cases, an individual will have be able to have a neural network that can be used in production. So if you think that each of those iterations takes 1 week to do, it's not really going to be feasible. So what is really important is to be able to reduce that time so that people can do more training iteration and eventually get to the final result. Very often there's some tuning happening, so that's why we have to do the training multiple times, because maybe the data is just not right, or maybe something that needs to be adjusted, right? So unfortunately, it's not just a one exercise, one training, and that's it. It requires multiple instances to refine the network design and correct issues in the potentially in the data set. So that really is the only really way in which you can make this productive, because you may not make people wait all the time, especially if you have a group of people. And of course, you need data scientists as well. People understand data. AI is not really necessarily a computer science problem. It is also a computer science problem, but mainly it deals at the center of it with data. And we need people who understand data and are able to utilize deep learning frameworks and neural networks to be able to train them on data to understand other data. So why DGX is an appliance? Okay, so it comes uploaded with OS and a lot of software, and we really package everything and tune it for maximum performance. And what we do is that we make available very frequently with new updates many common deep learning frameworks optimized to run training on our GPUs, and we package them in Docker containers. So it's very easy to download the latest version onto the DGX and be able to use that. Again, what we try to do is have a turnkey solution that you no longer have to spend weeks trying to set up and tune a system to do deep learning training, and instead focus on the key thing, which is training a neural network to do a task. That should be really the job at hand, not being a system administrator. So we took away all of that aspect, and we made an appliance that you just switch on and start to do deep learning training in 10 minutes. Okay? So when we look at the enterprise, how do we position this, and how do we are going to see how do we apply it. So now that we're getting in there of cognitive computing, it's clear that every system, every product we develop, every application, every service has to be more intelligent, and that's really, really critical. So this next level can only be achieved no longer by hand-crafted algorithms, but only by applying AI type of technologies and deep learning to be able to have better services, particularly in forecasting and predictive analytics, and also being able to do better recommendation and be able to achieve more insight in our data. And the data that we talked about comes from IoT, comes from a variety of sources, and now that we get into AI, the data set is really, the size is something very, very scary. If you see the word zettabytes, where many people are already scared when you talk about exabytes. But that is the kind of data volumes that we are talking about nowadays. And to be able to make sense of that data, we can no longer just store it, but we need to analyze it on the fly, and we need to be able to use AI to deal with that kind of volume of data. So of course, there are many examples. I think that we have here Mount Sinai, the use of AI to predict particular diseases by using different type of data. The nice thing about AI is that it can make it very easy to correlate data set which might not really be easy to correlate for us, for example. Certainly in medicine, they correlate medical imaging with maybe blood tests, electronic health medical records, and so on. In cyber defense, there are now systems that can look at the network logs or system logs of many devices and be able to analyze the data in real time to identify very advanced threats, and so that it could be complex attacks happening, not easy to identify, but with AI, they can actually look at the overall system and be able to correlate information and be able to identify more easily when there is an anomaly happening. Of course, improving customer experience and maintaining, a productive service. I mean, certainly there was just a video that recently was released in which a UK company that provides online shopping services for groceries had a series of robots going all over the place that picked up all the items and put them in the basket. So it no longer uses people as pickers to be able to provide even a faster service. And even in Singapore recently, Amazon released a service in which I think within 2 hours it can deliver your groceries. So you place the order and it guarantees that within 2 hours you will receive them. So this kind of ability to interact with the public in a more real-time way, it's something that is becoming more and more common. And of course, consumers' expectations are becoming higher, and companies have to respond to that, providing better services to remain competitive. Weather forecasting, I think this is also very relevant in Thailand, and I've been working in Southeast Asia for many years, and I've also had many contacts with TMD, the local agency for meteorology, because Thailand is a large country. It's also affected by sometimes by monsoon, by certain type of weather patterns, and both for agriculture, for transport, for people's safety as well. It's very important to be able to accurately predict weather, and AI is also helping in that. Going to the next level when it comes to weather forecasting, being able to provide more accurate weather forecasts, also with a shorter amount of notice, or even look and better understand the climate in general. Of course, it's also being used for satellite imaging. That's something else, very, very important and very interesting. For example, analyzing satellite images, right, or aerial images. These are huge images, and it has to be looked, with a human eye. It will be very, very time expensive to be able to go and classify. Now there are neural networks that are trained to look at aerial images and be able to identify this space is a house, this is a tree, this is a road, and being able, of course, to tag and segment images to create maps, really, without having too much human intervention. So again, very, very important for this very, I would say, very, very challenging tasks, because they're very, very repetitive, not always easy to carry out in volume. So how do we go and start? Let's say that tomorrow you want to either start a deep learning project, or you're a company, or in a company you want to either use AI, or maybe you want to develop a product using AI, or you have an idea and you want to implement it. So first of all, let's see how the workflow is actually the full workflow of the training neural network. So we start with a model. Okay, this essentially is a blank neural network, right? So think of it as a blank brain. The structure of the network is defined, okay, but there is no data, there's nothing memorized, okay? So we take that, and there are many available online models that are already being used for specific use cases, so someone can just start from that. Very often you'll have to modify or adapt the structure, okay? But that's something you can find online. Then we start with the training. The training, you'll have to use data. Data is critical to be able to train, and how do I know when it's done? Well, there is no progression bar. It doesn't say 100% complete, okay? The way the training works is that periodically, same as people in a school, you will do a little test and check how good it does. And when the test passes a certain mark, let's say that its score is 95%, you decide really, you can stop the training and say, okay, now I give you the degree, you can go to work, right? So that's really how the training works. So periodically you would check the accuracy by testing it with data. And testing it with data that was not used during the training. Otherwise, the same as you go to school, and then when I do the test at the end of the year or a periodic test, I use the same exercises that were on the textbook with the solution. That would not really be fair and it would not be accurate. So we always have to use data that was not used during the training. We keep aside some data only to be used for the test, data that was never seen by the neural network. So when we're done, we've got this trained neural network, and then we can deploy it. We can go to work. And that phase we call it inference. And in inference, we will have data, for example, pictures of cats, that will be shown to the neural network, and the neural network will be able to say, yes, this is a cat, or no, this is not a cat, if that's what we train the neural network to do. So of course there are many challenges in being able to apply these technologies, but these challenges are really being dealt with quite well. So it's getting better and better. So first of all, we need data scientists, we need people that understand this kind of technology, and there is a big demand. They're very highly paid in US. So we need more people trained in the area of data science, okay, to be able to understand data and then apply the neural network technology in the right way on that data. The second one is that it's a still fairly new area, so the algorithms, the neural network models, the frameworks, they're changing constantly, okay? Everything is changing every day, there's something new is refining. So there has not been any standardization yet on one particular type of technology. That might or might not happen, we'll have to go and see. NVIDIA really supports all of the top deep learning frameworks, so it's not really a challenge for us. Fast training, as I mentioned, one of the biggest problems people use deep learning is the training is too slow and they want to do more and it's just slow. That's where NVIDIA comes in to make it fast so that you can complete the training quicker, so that you can try more iteration or you can try bigger network and eventually you can be able to go to market. And of course, deployment platform, is this neural network going to be deployed as part of a web service for an app, or is it going to be deployed to control a car? Well, those will make difference, right? There are different products to be able to achieve all of that, and we'll do that in a moment. So example type of tasks that I might train a neural network to do. Now, these are all linked to images, right? But I could also look at text or voice or data frames or other type of data, okay? So this is only an example. Deep learning is not just for images. So we have image classification, so be able to tell what's in an image. We have object detection, so identifying multiple type of objects and then classifying what they are. And segmentation, not just identifies something, but also is able to tell you the exact area of the image that is covered by that particular, and that's very important also in medical imaging, for example. The other part, apart from the hardware that we're going to talk about in a moment, is the software. The software is very important because we need an environment to design our neural networks. Now, if you really want to try this out and you're new to it, I would really recommend that you go and download NVIDIA Digits. Why? Because it's a tool, web-based tool. All you need is a GPU, even if it's a GeForce GPU, it will work, that allows you to design a neural network without having to write any kind of code because it has a web interface. So you can do everything by clicking around. So anyone really can go and design their own neural network and train it. And then we of course have the deep learning frameworks that you might want to use to implement your own particular use case. And NVIDIA, none of them are made by NVIDIA, we just support them. And of course we have a number of libraries that go below, under the frameworks to be able to speed them up, utilizing the GPUs and be able to perform deep learning training and inference tasks faster. So the availability of GPUs is everywhere really. So there are many common server vendors who have the GPUs in their catalog, so you can have a buy server with some GPUs. There is the NVIDIA DGX appliance, okay, which is of course the fastest one to be able to do deep learning training available, including in Thailand. And of course there is also cloud services. For small experimentation, it can make sense. But I think if someone starts to have many people using deep learning, or long, then it can become a bit expensive to use cloud. So these are really our products. We have the DGX server, and then we have also a DGX station, which is half the size of a DGX server, but it can actually go under your desk. And then we have the product for inference. So we have system, of course, for cars or for robot or for devices in the field, such as IoT, as well as cars that can go inside servers in a data center. Now, another way that you can expand your knowledge on deep learning is the Deep Learning Institute. We are running periodically trainings here in Bangkok as well. We will run a few. We hope to organize more in the future. These are full-day workshop in which you learn how to use deep learning for a particular, to be applied for a particular use case, okay? And we have different examples of use cases. The most important thing is these training are not academic. You don't require any background knowledge. They're very, very practical. They're very applied, and they are hands-on. So each one of you will be able to connect to through the internet, through a cloud environment, where each of the participants will be given a GPU and the software environment ready to be used. And then again, you can use that to learn how to at least apply that to that particular use case. So I think it's really a good step if you really want to go a bit more serious into applying deep learning. We have some courses online that you can take on your own if you could visit our website. Otherwise, as I said, we also have these instructor-led classes that we're running in Bangkok, and they will be very, very much hands-on and very, very practical on how to apply. There's a lot of news. I really recommend that you join or regularly review our either join our newsletter will be the best thing. But in particular, we have a blog in NVIDIA where we always talk about different use cases on AI and new things that are coming out. So that is a very good source to see which are the areas that people are applying AI, and maybe it can be an inspiration for a new service or something new that you might want to implement here locally in Thailand. So the really key takeaway, depending on how much you've been able to understand today, is really that AI is for everything and is everywhere. Okay, and every single business has areas in which it can take advantage for itself to be more efficient, to be able to target their customer better, and also it can be used as a product in itself by embedding in an existing product or creating new products that can take advantage of AI. Okay, so that is it for me today. Now if there is Q&A, if anybody has a question, in particular if you have, maybe you want example of particular potential use cases in a particular area of industry, I'm more than happy to go and mention some. Any question at all? Okay, we'll have a summary, I think, do we? We'll get a chance to do a summary in Thai.
มีคำถามได้แต่ผมขอสรุปเป็นภาษาไทยสั้นๆนะครับว่าในแง่อินเดียเองเนี่ยจากที่พี่เซมาเขียนว่า AI เนี่ยมันอยู่ทุกที่แล้วก็ใกล้ตัวเรามากนะฮะในแง่ในฐานะเราเป็นสตาร์ทอัพเป็น EID เนี่ยนะยังผมมองว่าทุกแอปพลิเคชันที่เขาโชว์เนี่ยไม่ว่าจะเป็นสามารถบอกภาพต่างๆได้รวมไปถึงแอดวานซ์ขนาดแบบช่วยเลือกสินค้าได้พวกนั้นเนี่ยมันเป็นโซลูชันที่คนไทยเราสามารถสร้างได้แล้วผมมีสตาร์ทอัพหลายๆที่เขาทำโปรเจกต์พวกนี้อยู่ในแง่อินเดียเองเนี่ยเราเอาไว้เทคโนโลยีเอาไว้ซอฟต์แวร์และให้การอบรมนะเรียกว่า Deep Learning Institute นะฮะก็ถ้าสนใจเข้าไปในเว็บไซต์ NVIDIA เข้า Inception โปรแกรมได้นะฮะสมัครแล้วเราสามารถไปเข้า Training Learning ได้หรือถ้าสนใจก็กรอกในแบบฟอร์มของ Dell นะฮะเขาก็เดี๋ยวจะส่งข้อมูลกลับมาให้นะครับก็เชื่อว่าในแง่เทคโนโลยีนี้เริ่มต้นไม่ยากนะฮะมีได้สองแบบคือเอาไปใช้กับสามารถถ้าเรามีโปรแกรมมิ่งก็ทำโปรแกรมมิ่งได้นะในนั้นก็จะมีรายละเอียดอยู่พอสมควรครับไม่ทราบก็คงประมาณนี้นะครับถ้ามีคำถามอะไรก็เชิญที่บูธก็ได้ครับขอบคุณมากครับ
ขอเสียงประมือให้กับมิสเตอร์วอลเกอร์และคุณไพโรจน์ค่ะ Thank you very much Mr. Walker for the presentation ท่านผู้มีเกียรติคะขอความกรุณาทุกท่านนะคะกรอกแบบสอบถามให้ครบถ้วนนะคะท่านใดที่ยังไม่ได้รับสามารถ ามารถรับได้ที่จุดลงทะเบียนนะคะเมื่อกรอกเสร็จเรียบร้อยแล้วคือเสร็จเรียบร้อยแล้วก็จะได้รับของที่ระลึกนะคะจากทางงานและนอกจากนั้นแล้วนะคะขอเชิญทุกท่านเยี่ยมชมโชว์เคสนะคะตัวผลิตภัณฑ์รวมไปถึง solutions ของทาง Dell EMC Microsoft NVIDIA รวมไปถึงพาร์ทเนอร์ทางธุรกิจของเรานะคะที่ฟอยเออร์บริเวณด้านหน้าด้วยสำหรับวันนี้ค่ะในนามของทาง Dell EMC Microsoft NVIDIA และพาร์ทเนอร์ทางธุรกิจนะคะต้องขอบคุณท่านผู้เกียรติทุกท่านที่ให้เกียรติมาร่วมฟังการบรรยายนะคะณบริเวณห้องเวิร์กช็อป 4แล้วก็ในวันพรุ่งนี้เราจะกลับมาพร้อมกับหัวข้อต่างๆนะคะตั้งแต่เวลา 10 นาฬิกาเป็นต้นไปสำหรับวันนี้นะคะดิฉันเมย์ชดานิคำนวณหมดหน้าที่ลงแล้วค่ะสวัสดีค่ะ